So I would recommend having your notebook out and having Desmos 316 up and running as we go through this. Okay, so this is something I'd put in your notebook. So you should know a quadratic equation is just a polynomial with degree 2. That just means that your highest exponent is x squared. When there's an x squared in the equation, you might have two real solutions, one real solution, or two imaginary. And we'll look at all these options. So we've already done solving some quadratics before. We've used factoring and we've used square roots. Now, it's really important that you understand when you can use factoring and when you can use square roots. You can only use square roots if you see a single x in the equation. See how this has an x squared and an x? So you can't use square roots. This one is actually factorable, or you can use square roots because there's just a single x squared. There's just a single x squared, just a single x. So let's look at each of these and the different methods that you can use. It's going to be, Desmos is going to be picky about how you answer your solutions. First of all, if there's an x squared and an x, you always want the equation to equal 0. So this first one does. Notice there's a GCF of x. So factor out the x. Then it's been a little while since we've done this. We just split it apart, set each, you're just looking for the zeros. So x equals 0. And what makes x minus 6 equal 0? When x equals 6. This is what you can't just type in 0 and 6. It must be x equals 0. So Desmos is super picky when it comes to checking your work. So it's got to be just like that. Okay. Now let's look at both the methods for the second one, because we've learned how to factor. This is called the difference because it's subtract of two squares. So we can factor. There's no GCF, so we're going to break it into two parentheses. What makes x squared? X and x. I'm going to tell you right now, you never get away from factoring. Every single class I teach, we factor. Then factors of 16 that add to 0 because there's no x term. So this is just plus 4 and minus 4, because these multiply to get negative 16 and add to get 0x. So the solutions, we look at each one, what makes each one equal 0. X equals negative 4. X equals positive 4. All right. But let me also show you, since there's just an x squared, the other thing you could do, you could add 16 to the other side, square root both sides, and x equals plus or minus 4. So when there's an x squared and you use square roots to solve, you always need the plus or minus to give the two solutions. So either way, we get positive 4 and negative 4. So up here, x equals negative 4 and x equals positive 4. And you get that by either method, so whatever you're more comfortable with. All right. So the next one has both an x squared and an x. So let me just say this. If you've got both the x squared and the x, you have to factor. You have to factor. If you only see a single x, you can use square roots. So go ahead and try these next three. Maybe pause the video and work through these, see if you can find these answers. Okay, so we're going to, here, let me come back to this last one because I want to make sure you found the right answer for this. We solved these way back before Christmas. How do I get how do I get to the x? How do I get rid of the square root, both sides? That takes the square, and I'm left with x equals, or x plus 2 equals plus or minus, because I used the square root. Now you have to break down the square root of 20. That's what we've been working on the last week or so. One of the things. So what perfect square goes into 20? 4 times 5 makes 20. So that's plus or minus 2 square root of 5. Then I got to move the 2 over. So if this is on paper, I would be okay with -2, and I'm just going to push over the plus or minus 2 square roots of 5. In Desmos, though, you need to separate it. So this first answer is going to be -2 plus 2 square roots of 5. And then the second answer is -2 minus 2 square roots of 5. So this is really slick. This is actually much easier than if you try and get rid of, if you distribute this all out and make it complicated. Anytime you can get the equation into this format, it actually makes it easier to solve. And that's what we're going to be looking at in this next slide. Okay, perfect squares can be rewritten if we factor x squared plus 8x plus 16. We get x plus 4, x plus 4, which means I could simplify it into x plus 4 squared because there's two of the same thing. So let's try and factor the rest of these to see if any of them are factorable or can be written in a perfect square form. So x squared, we have x and x. Are there factors of 25 that add to get 10? Plus 5, plus 5. And these are exactly the same. So that means I can rewrite this as x plus 5 squared. All right, how about this one? Are there factors of 29 that add to get 10? No. So this one's not even factorable, so we can't even do that. All right. Are there factors of 8 that add to get 6? Yes. So x and x. 4 and 2. I need a positive 8, so the signs are the same, and a -6, so they're both negative. But this time these two don't match, so there is no perfect square form because they're not the same. All right, how about this one? Are there factors of 9 that add to get 6? Yes. 9 is 3 minus 3. And this time they are exactly the same. That means I can rewrite them in perfect square form. So then you're just supposed to check off which one of these create perfect squares after you factor. Now, this question down below, what's the pattern that you see in the original quadratic that you would know it always works to be a perfect square? So what's true about this number and the linear term, this middle one here? 3 is half of 6, and 3 squared is 9. Half of 8 is 4. 4 squared is 16. Half of 10, 5. 5 squared, 25. So what we're going to do is convert our quadratic form into perfect square form. And that's going to help us see another way to solve. All right. So we need to find half of this number and square it, and that will complete the square. See, the C represents one specific number that makes this quadratic able to be rewritten as a quantity squared. What does C have to equal to complete the square? C equals 100. You take half of this number, square it, and that's this number. Okay, so try that for the rest of these and then go ahead and submit. So let's see how we can use this to solve. All right, so there's really only one number that can complete the square. So typically I always want the constant value on the other side of the equal sign. I would write this out in your notebook so you have an example of exactly how to do this process. I'm going to draw a blank there so we can fill in the blank with the number that completes the square. Then whatever we do to one side, we do to the other. All right. I always like to do the parentheses first before I complete the square, but it doesn't matter. First of all, the x squared cannot have a coefficient, so always make sure that you start by checking that. We always put our x first, take half of this number, and if it's positive, it's positive. If it's negative, it's negative. So you take half of 10, which is 5, and then you square it. 5 squared is 25. So we're going to add 25 to both sides. So we just, what we just did here, and I'm going to go ahead and add the right side, 3 plus 25 is 28. Our goal is to convert the polynomial into a perfect square. Because now we just have a single x, and I can solve it by using square roots and inverses to get x by itself. All right, so the first thing we have to counteract is our square. So we're going to take the square root of both sides. So the square root undoes the square. So I'm left with x plus 5 on this side, plus or minus. I have to break down 28. So that's perfect square that goes into 28 is 4. And square root of 7. Square root of 4 is 2. Square roots of 7. Then final step to get x by itself is to minus 5 from both sides. So x equals negative 5 plus or minus 2 radical 7. And remember, when we want to write this as two separate answers, we have negative 5 plus 2 radical 7 and negative 5 minus 2 radical 7. And that's how we use completing the square to solve quadratics. So let's try the next one. Okay, remember how I said there's only one special number that complete the square? 8's not going to be it. So we have to move the 8 to the other side. That looks kind of messy, sorry. So I leave the x squared plus the 6x. I draw a blank. I move the 8 to the other side by subtracting it, because that's the inverse of adding it. Now I complete the square on the left side. So I want to find the number here that completes my perfect square here. So x, we always start with x, and there's no coefficient here, so that's good. Half of 6 is 3. What number completes the square? Is 9. And a lot of you can probably just take half and square in your head and get this number right away, and that's fine too. But you want this number to be half, and this number, you take it squared. Then you simplify the right side, which is 1. Now we just need to solve for x. So I need to get rid of my square by using the inverse, square root both sides. So x plus 3 equals plus or minus the square root of 1 is 1. So I have to just break that down. Then to get x by itself, I have to subtract 3. Now, let's think about this. X equals negative 3 plus or minus 1. So if it's negative 3 plus 1, what is that value? Don't forget your x's up here. Desmos, you got to have x equals. Negative 3 plus 1 would be negative 2, and negative 3 minus 1 is negative 4. Now, if you recall, we did this one earlier using factoring. Let's see if we still have that. Right here. Oh, this was a minus, but. So quadratics can be solved multiple ways. There's sometimes that they're easier and some ways are harder. And sometimes we don't have options. Okay, so if we're going to use completing the square, what value of b would lead to a solution so that I would not have a fraction? What do I always do to the linear term? I always take half of this. So then that means b has to be even, and then there's no fractions. Okay, so these are just several different methods. You can use your square roots, factoring, or complete the square. So think about what would be the easiest way to get x by itself here. What would be the easiest way to get x by itself here? So I want you to kind of go through and choose. And then go ahead and use Desmos. Check having Desmos check it for you. And email me if you've got any specific questions. All right, so what this last slide does, the last flip chart, shows how we find our final method for solving quadratics. There are times that you can't use square roots. It's not factorable, and completing the square is just not nice. And so what we do, mathematicians developed a formula to solve all quadratics. So what we're going to do is use this most basic quadratic equation, and we're going to get x by itself by completing the square. So I'm going to show you these steps, and we're going to develop the formula itself. And this is going to be one of my favorite things because I like the formula. Now, remember what I said earlier is you cannot have a coefficient next to x squared. So if anytime there's a number, we have to divide the whole thing by that number. So notice my reason here. We're going to divide everything by a. So our first step is if I divide by a, then we just have x squared because the a's cancel, plus b over a x. And we have a lot of fractions. You're going to have to suck up the fractions here, equals 0. All right. I think what I might do this in using my equation editor. Hang on a second. This might be a little nicer. Just bear with me. All right, so x, I have to deal with this in its own little way. X squared plus b over a x plus. This might take us a little bit, but it might be easier to read. Okay. Then the next step is, this is not going to be our perfect square number. So we need to let's see if I can just manipulate this now. So I want to move the c over a over. So I have to subtract negative c over a. So I'm going to make room for that number that completes the square. Then we have to complete the square. How do I find half of a fraction? I'm always just dividing this number by 2, right? So I'm going to turn this into a quantity squared. So I'm going to get rid of this square here. Well, this isn't going to be. Oops. Let's see. Yeah, this isn't the best thing. All right. Now, the one thing that this, so I'm taking half of this and squaring it. So what is it that I have to add to both sides? I have to square b over 2a. So I'm going to fix this and complete the square. So that's b squared You can see all the issues we have when we're dealing with this. Okay, b squared and 2a squared is 2a times 2a is 4a squared. And I have to add that to both sides. And so then I got to come down and add that down here. But I'm going to put that in front of this, like that. We now have to get a common denominator here. This kind of is a mess. I'm sorry about that. Let's see if I can make this a little bit bigger. Okay, now we need to get a common denominator here. So I'm going to multiply this by 4a top and bottom. Let me just do this. Times 4a top and bottom. And so I'm going to put this all over 4a squared. So really, since these have a common denominator, I don't need two separate ones. So what let's do, get rid of this and just extend this out. So I'm just going to get rid of this whole thing. Oops, not that whole thing. That whole thing. And put in the numerator here minus 4ac So I'm kind of doing, what we were doing before with completing the square. I move the c over. It makes it extra complicated because I have an a in the bottom with my fraction. Take half of this, square it, add to both sides. This time I had to get a common denominator. Then I'm going to square root both sides to get rid of the square. So I just have x plus b over 2a equals plus or minus, because we took the square root, and I'm just going to put the square root over the numerator, b squared minus 4ac all over the square root of 4a squared is 2a. And to get x by itself, I just move the b over. And this is what the quadratic formula is. X equals opposite of b, because we had to subtract it, plus or minus the square root of b squared minus 4ac all over 2a. Some of you recognize this. You learned this back in algebra. So we're going to get into this tomorrow, the next day.